Water is a powerful agent of erosion and weathering. Physical weathering occurs in rivers all the time as water moves bits and pieces of rock downstream, things we call sediment. Here we're going to do an experiment to demonstrate how larger bits of rock or sediment are broken down through time during this process into smaller and smaller sediments. What have we got here, Allison?
We have chalk. Why are we using chalk?
Well, that's a good question. So we're using some blue chalk, and the blue chalk is going to represent boulders in a stream. So we're going to kind of break it up into some chunks, like a boulder that rolled off a mountain, and we're going to put them right into the jar there. Now these boulders in the action of the river will move around and bang together, and they will eventually break apart. And that's what we're going to simulate here today. The thing that's going to really help this boulder break apart are other minerals in the stream, right? And so if this jar is our stream and our boulders are in the stream, we need other bits of sediment to help break it down. So what can we use?
We have this ice cream salt here.
Let's use some ice cream salt and maybe some of the sea salt over there. So now that we have our blue boulders in our jar river, we're going to pour some other sediments and materials into the river to help grind those boulders down. And we've got a mixture of two different sizes of salts. This is sea salt. We'll pour a little bit in there, and then once you pour some of the coarser ice cream salt or rock salt in on top. Now, just like chalk is a real rock, so is salt. Salt is the mineral halite, and it's a very common thing in nature. So we've got two different minerals now in this river. So what we want to do is screw on the lid. All we have to do now is apply energy and time. I'm going to ask you to shake this as hard as you can.
It's turning blue.
So so stop for a minute. Let's look at this. What is happening here?
The color from the chalk is going into the salt.
Yeah, so is the actual piece of chalk in there starting to change?
Yeah.
What's happening to it?
It's getting smaller.
It's getting smaller. Let's shake it a little bit more. So now we've shaken and shaken and shaken and shaken and shaken. So it takes a lot of energy to break that boulder down, doesn't it?
Mm-hmm.
Matter of fact, I could just lay down and take a nap. I'm tired now. That river's doing a lot of work. But if we open the lid, what do we see?
This piece is really small.
Yeah, there are a lot of little smaller
texture.
pieces. We don't have one big piece anymore. It's broken down into smaller pieces. In fact, some pieces are very small. So here you can see the piece that was in is now rounded on the edge, and it's not squared off and sharp like the other piece. A lot of those little bits and pieces around the edge have now broken off and are in the powder in the bottom of the jar. Let's go ahead and pour out some of the salt and chalk mixture onto this white cutting board so we can look at it more closely. That's good. So if we look very closely, we can see many different sizes of grains are here. Some of them are very, very fine, almost like a powder. We would in nature call that silt. Silt is a very fine-grained sediment. Some of the coarser material we would call sand. Sand is like the stuff that you walk on the beach. It's kind of coarse and grainy. Even some of the larger pieces here we would call coarse sand or very fine gravel. Some of these larger pieces in a river, though, still hang out, right? This is why you still see boulders in rivers. Not all of it is eroded away yet. Just need more time and energy.